Hi, my name's Max. I work at a company called Fused. We do Python serverless compute, and we're going to talk about that, and we're going to talk about why finding titles for stuff is a bit complicated. Before I get into the technical stuff, I want to zoom back out a little bit, and I want to talk about this one graph that I've shown like every time over the years when I went on stage. It's this graph. You've probably seen it before. You've probably seen something similar. If you're here, you know what this means. There's been an explosion in the amount of Earth observation satellites over the last decades. So like it feels like, right now things are pacing up. We were talking about SpaceX, but this is a trend that's been going on for a really long time. And I think there's a lot of really interesting second order effects with this graph. And this graph, I've seen it before in a bunch of completely unrelated stuff. And this is a thing that I like thinking about. So this is from Our World in Data, and they show this explosion in the amount of book productions. And bear with me, there's some related stuff. And so like we've been writing for a very long time. And once we started writing things, like there's a really big change in like what it means for humanity. I know I'm going really big here, but bear with me. In about 3000 BC, like that's when we start the invention of writing. People start writing, and that's what we define as history. Like it's a pretty big deal that like people started writing things down. They had this information, they went and found a way to store it. And we've just kept on putting more and more stuff out there. There's more books, but the second order effect of that is that we had to invent the library. We don't necessarily think about it that much, but the library is this place, it's this tool that's good for storing things and finding books, like storing books and finding them. It has this dual purpose. And we might not think about it because it's just a building now, but it's actually a technology. It's something that's evolved over time as we've had more and more books, and even the way that we keep things that are written down has changed over time. So let's go down a little bit of a nerdy history rabbit hole of like how have people stored information. And so you have like, okay, we figure out how to make clay and we can write stuff in it, and like great, that's how we start writing. It's a bit bulky, it's not the easiest to store, indexing, like that gets a little tricky. Someone figures out that you can get papyrus and you can make scrolls out of it. Density of information goes up, but it's still super fragile and it's a bit hard to index. You have to roll it up. Eventually, paper becomes easier to produce, and there's the leather-bound book. Now, there's a title on the binding. I can put it on a shelf. I don't have to actually open it to figure out what's inside. I can put something on the binding. It's also a lot more space efficient because they're like rectangles. I can just store them on a shelf. And then there's a protective casing. That's just like also it means that that data can be stored for a much longer time. The thing is like to be able to access that, you need to be able to read it somewhere. You want to put that in a building so that these things don't, if it rains, it doesn't get destroyed. The thing you might think about is like at the time, no electricity, but candles, probably big no-no when you have paper. And so why am I talking about this? Why am I going on this whole tangent? Because I think about how the libraries were designed. It means that to be able to read books, you need to have windows. And at first, windows are really hard to build in buildings because it's a pretty big challenge. You have to put a hole in a wall. But eventually, over the centuries, we get a lot better at making a lot larger windows. And you can see this in the way that libraries were designed. So this is, I forgot when it's from, but what you can see is that this library and these ones, the windows get bigger, but the design of the library still stays the same. These shelves, they're perpendicular to the walls, and there's a very specific reason why, is that that's how you get sunlight that comes in and you can read what's on the binding. If you put all these bookshelves parallel to the walls, you can read the first set of books, but you can't read the other ones. So the library, the way it's designed, is tied to the technology at the time. You can't have electricity. So you design libraries like this all across the world because they're bound by the same limitations in technology. And then it's not just about the shelves. It's about like how you sort them, how you make it findable. Of course, I had to put an XKCD comic because this is a nerdy presentation after all. And this is like the same, it's a book. You put all the words, you keep them the same, but depending on how you sort them, it's like a mess. There's also sections, like Jed is not here, but if you know anything about Jed, you've probably heard him talk about Dune a lot. And in a library, you know that like you can just skip this whole section. You don't have to open every single book. You don't have to read every single binder. You can just skip right through, get to where you need. This is what I think a lot about, is like libraries, they were limited by the tech of the time, and we're on the exact same curve, and We're basically building libraries all over again. We're limited by the amount of books there are, by the tech that we have access to, and like that's what I think about when a lot of the talk here is about like how do we build basically libraries for data. It's just we're not on clay tablets anymore. We still have books, but we have a lot of digital stuff. So now let's get into the like, okay, what are we actually talking about here? I want to talk about Overture Maps Foundation, and you've probably talked about here if you're not familiar. It's this open repository of data. They have building data sets, building footprints, and actually this is not quite on their website anymore, but I'm going to keep this sneaky screenshot. You can go download the data, and then they had this section of like, what if I want all the data? And like, really, maybe you shouldn't actually do that. Maybe you should just figure out what you want and just get that, because otherwise it's really, really big. To me, that's the equivalent of walking into the library and saying, can you give me information about any books? And they're like, no, just the religion, or just the philosophy, or just science fiction. I want to walk into the library, and I want you to be able to tell me anything about any book, because I don't necessarily know ahead of time what I'm going to want to pick up, which book I'm going to want to read. I do want to access all that data. I do want to go to Overture and say, just give me everything and let me figure it out. And so one thing you can do is you go to the S3 bucket and you say, okay, just like list everything and show me what's there. And so if you do that, this is the list of all the books, basically. The problem is I don't know what any of these mean. And I can go read the metadata. I can go figure it out. There's the Explorer as well that's really good at figuring out where it is. But going from like using this, figuring out just what I need, there's still a bit of friction there. I just want to walk into the library. I want to skip through everything I don't care about, and I want to just get the data that I want to use. And so this is where I come in and I say, hey, we're the silver bullet. We're going to solve all the problems and all that stuff. No. But we are very opinionated in the problems that we want to try to solve. We want to optimize for that iteration speed, specifically for people who are manipulating the data, so like the data scientists. Basically, we want to make the library a lot easier to work with. And so there's a few things of like, what does that look like concretely once we go into the nuts and bolts of it? There's three main things that we're doing. We have pretty strong opinions about how to ingest data and how to sort it. We're building serverless Python, and I'll get into why and what that looks like. And we've also built a web IDE that's really meant for iterating a lot faster. So if I go back to my Overture example, I start with the data ingestion. This is all of Overture, but we've repartitioned it so that in a map I can just zoom anywhere I want and say I want to find this specific building. I just zoom in there. I know where it is on the map, and I can then have access to all this data. If I play that again, at first you see this is the entire data set. We're making that a lot easier to just stream that data to just work with it. And you might be saying, like, great, that's really nice. I can probably do that in the Overture Explorer as well. But I'm going to focus on the data ingestion. It's not about file formats. This is comparing, again, what I did earlier. We just list the directories. They're parquet in both cases. It's not just about like the file format that's faster. It's about like how do you organize stuff. It's not about just the books. It's about how the shelves are built so that it's very easy to get to what you want. Yeah, there, I should have shown that. But yeah, once you get the data, like you actually want to do stuff with it. It's all really nice. Okay, I found that building I care about, but I actually want to do things with it. And so the one thing I've learned with over the years as being a data scientist, that this is what tends to happen. This is what my laptop would look like if I were, okay, I'm going to try this algorithm. Wait, actually, no, now I want to try that algorithm. Or wait, there's a new release of Overture. Let me try something else. This is the reality of what it's like to be a data scientist. There's always a new library that comes out. There's always a new data set that comes out. It's just a lot of iteration. And so this is where the serverless aspect comes in. So this is Workbench. This is our web-based IDE that's running our serverless Python. On the left is code that I'm just editing as I go. And on the right is just a map view where I'm just going to execute that code over the not the entire Overture data set, but just this window that I'm looking in. So I can just zoom into anywhere I want, and then I can start saying, I have access to all of Overture. I can calculate the area on the fly, and then I can say, just give me the buildings that are above 1,000. Actually, wait, you know what? Just give me the buildings over 500, and then on the fly, I see what it looks like. This is what we're building. We're building these user-defined functions. It's just running here. As you go, you can see what it looks like. It's this iteration. We want to give you access to the entire library, but we know you're just working on a small piece at first, and then you want to scale it. And then you want to come back and you want to iterate again. Like that feedback loop is what we want to iterate for. But we're trying to make the compute faster. We don't want to lock you in, okay, you have to bring all your data onto our special magical bucket, or you have to use this. No, we want to get out of your way. So every UDF that you have, you can directly go to a setting that we have, and we always create a URL to it. It's directly deployed. Every time you save the code, it gets deployed, and you get this URL. And you can do whatever you want. This is a HTTP endpoint. You can call it wherever you call HTTP endpoint. You can put that to your front end, and if you have a whole new map layer. Or you can even just dump it into an Excel spreadsheet because your business developer guy really, really likes his spreadsheets. And you can see, like, we're doing the filtering that we had. I said I wanted to filter buildings above 1,000 square meters. I only have buildings that are over 1,000 square meters here. You can directly call it here. Like this is, I can ask to get that data directly as a JSON, and I have it here. You can also call this from anywhere that you can run Python. So this is just a Colab notebook, and all I need to do here is install Fused, import it, and then I say run this specific UDF for this XYZ tile, and I get a data frame back. I did a query basically to get all of Overture to say, hey, I just want this section, pull it back to me as a data frame. And I can do this. I did it in Colab to show you that, like, you know it's true because it's untitled. I just opened a new notebook. But you can do this locally. Like, you can just call this giant data set and return back this small data frame that's just this area that you might know. And then you say, okay, but wait, actually, I still want to change the code because I realized I didn't have the right parameter. And then the moment you save that and you call this function again, it's directly updated. We just deploy the code every time you save it. So we're making that iteration of, like, I have a result, I have a new data set, I write some code, I push it, and wait, actually there's something new that changes. Because that's the reality of it. I want to go back to specific ingestion and tiling and things like that, of like, how do you put things? One thing that we're getting a bit opinionated about is we want to double down on hexagons. So this is the H3 tiling system. If you're not familiar, it's basically tessellating the entire world in hexagons, and there's a bunch of reasons why this is really interesting. First of all, hexagons have this really nice property that just like a good tiling system, they tile down. So like at a resolution 7, that's the large hexagon, everyone can fit into roughly 7 hexagons, and you can go down and down and down. So like that's a really nice property of hexagons, and I'll also do some pretty cool stuff. So this is the crop data layer from USDA. It's this yearly giant file of 250 categories of crops in the US. And so you can go to their website, and there's a little filter, and you can go there, and I can say, show me just the tomatoes. Why tomatoes? Because why not? And they show up here on the map, but because it's just like a raster filtering, it's just these like tiny little things. What you can do is then, what we've done actually is you can just re-ingest that into hexagons, and you can then aggregate them by the area that you have. And so now they actually show up a lot more. You can see that there's a lot in California, and then there's just like random tomato farms all over the country. I have no idea why, but this shows up a lot easier. And then I can do it at a much lower resolution just to get an idea of like, where are the things that I care about. I can do this on, I'm just running serverless here, but then if I wanted to bring this back locally and just iterate on it, now I have a data frame that's just like 160 rows. Like, this is a tiny little thing, and I've just aggregated the entire data set into just these areas that I might care about. These are basically the areas where there's tomatoes. You might care about whatever crop you want. But this is where like the ability to sort this data and aggregate it makes it really easy to just find the places that actually matter. One of the other interesting parts of going towards specific tiling or specific data ingestion is you can bring in multiple different types of data sets. And so here we have tomato crops and we have census. So this is just population. But then these are different data sets because one is sparse, the other is dense. It's usually a mess to bring these things together. You have projections you need to deal with. Hexagons make that a lot easier to then just join it, and you can do some pretty cool stuff here, like just looking at which counties have tomatoes. Why do that? Because it's fun, and also because it just took 3 seconds to put that together. I can iterate really, really quickly. And I don't necessarily know what questions I'm going to ask, but that's the whole point of being a data scientist, is like there's a lot of exploring, and as data gets bigger, we need that number to stay the same. And you might be seeing this and you're like, yeah, sure, you can do all that with rasters. And that's true. And that's where we're a bit opinionated about what we think, which data partitioning and ingestion schemas we should use. And like H3 is like one of them, and it's really interesting. It has some pretty interesting features. It's pretty compute efficient if you want to aggregate things over the entire world or at a high, low resolution. You don't have as much projection issues. I come from a remote sensing background, and this struggle of like, I want a global projection, but then I want to calculate areas down to like very accurate, means it's projecting things all the time, and that's pretty tricky. There's some like interesting neighboring effects with hexagons, so if you want to do like aggregate statistics, it's pretty handy. And so the main thing is it's really nice to bring different types of data sets together and just like iterate. Because working with one data set is usually okay, but working with different data sets that come from different places that have different formats is always a bit of a pain. The one thing I want to mention is like we're still figuring out all of this. Like this is a bit opinionated, but in 3 years there's probably going to be different file formats, there's going to be different indexing, like all of these things are going to change. The iteration speed though is not. We're still going to want to go really fast. And don't just take our word for it. Like we are putting some of these stuff as we're iterating out. So on Source Co-op, we just published some of these repartitioned hex data sets. So we did census and CDL, basically the two that are here in this demo. And like you can see you can see the date here is April 29. That's like 2 days ago. So we're iterating on this pretty fast, and we're still figuring all of this out. The UDFs that I've been showing here, you can go try them out. If you go to this QR code, you'll go to Workbench, which is our web-based IDE. You might have to then send the URL on your laptop because on your phone it might be a bit small. But I'll also give the slides here. And you can try this out without an account to just like explore the data. We also have, I was talking about Overture earlier. We've repartitioned that, and that's what I was showing earlier. This is also on Source Co-op, so like, don't just take our word for it. Like, you can go play around with this. You don't even need to use Fused, but these data sets are already out there. I want to talk a little bit then to like wrap up of like, who the heck are we as a team? And I just want to show a little bit of like who the team is. So we have Sina that's in the back there, that's from, used to work at Uber, our CEO. We have Isaac that's not here, but he's our CTO. He's one of the core maintainers of H3. That's why I was showing a bunch of hexagons, because like this is the people that have worked on it. Joris has also joined the team a while ago, and he's one of the core maintainers behind GeoPandas, Pandas, and Arrow. And then there's just me that's just randomly here. No, I've been a data scientist for a really long time. I really care about trying to explain some of these stuff, because like there's a lot of change that's going on in how we process and how we manipulate data. Just as importantly, I think it's good to mention like, well, what do we not do? We're not a data company, and we're not a machine learning company. As in like, we don't create the data. What's on Source Co-op that we showed there, we didn't make that data sets. We just repartitioned it. And we're not an AI, we're not a machine learning company. We're not coming out with a better algorithms. You guys probably know that better, and it changes all the time. So to go back to my original analogy of books and libraries, we're not Frank Herbert. We're not writing the books. We're the New York Public Library. We're the people that are organizing it together so that when you go in there, you can find what you want, you get the books, you have the utility out of them. If you want to help us build some of that stuff, we're hiring. And if you have a lot of data or you're working with a lot of data, just try it out and come talk to me. There's a lot of really cool stuff that we're doing. Love to know what you guys think about it. And that's it. Thanks for your attention. Yes. And if you have any questions, yeah, if you can go up to the mic then.
Really, yeah, awesome work. I had two short questions. How are you prioritizing which data sets you want to partition and you want to include in your library? Like you showed Overture and Census, but then like, how are you going to decide which ones to follow? And then if you could speak more on the serverless kind of architecture. I know it's like a huge.
Sure.
But if
Yeah, we're doing these because like, honestly, like we're doing the ones that we're interested in, but you don't have to use any of these. Like this is just Python. You can plug in whatever S3 bucket you have. Again, we don't want to lock in or anything. We're just showing like what's possible, the impact of partitioning, the impact of like reordering that data. So we're really just doing whatever the ones that we're interested in. That's the very honest answer. But if there's any data set that's on S3, we have some demos using the planetary computer, for example, to get raster data. So we're just a bunch of nerds and we do whatever we think is nerdy. For the serverless, what we want to do is we want to make it scaling to whatever you're doing at the time. So to get into a little bit the nuts and bolts, we run on real-time instances. So every time, I'll go back to this part here. So we're just like running this continuously every time that you make a change. We're just spinning up a new small instance and then executing this. Then we have the ability to say, okay, if I wanted to do this over the entire data set of Overture, it doesn't matter how big your instance is, it's going to blow up eventually. So we have ways to parallel that as well. We have ways to do like really big instances if you want to ingest your own data, for example. I'll point you to like the docs and what we're doing to go into a little bit more of the detail. It's actually on purpose. We're not trying to go too much into the detail of like how it works, not because we don't want to show it, but because when you're working on this, it doesn't actually matter that much, like how it's running if it just runs. So we want to focus on like the value prop of like, this is what we want to show you and sell you on. And then like there's a lot of the details of like, how do you make the most out of it? Because if you want to scale these things, there's like, how big do you decide on your tile size? There's a lot of things like that where we need to help out a little bit.
Great, thanks.
Yep.
Thank you. That was a great talk. I've followed H3 for a while, since the Uber days and the Unfolded days, the Foursquare, and all the things. I'm curious, and I apologize, this is not a question directly about your talk.
Sure.
But your thoughts on A5 and pentagons.
Yeah, we were just talking about that at dinner yesterday. Honestly, like, I'm probably the least competent person in the company to talk about it. But what I will say is what we ended up talking about is like all of these partitions schemas, they're very young still. Like A5 came out like a few weeks ago. I think H3 is just a few years old. And so we have, again, we're pretty opinionated because Isaac and Sina are in the company and they've worked on that. But if someone came out with something that's a lot better, a lot more efficient, specifically at some applications, then yeah, let's go. Let's use it. So the answer is I'll go back to like, this slide of like, we have pretty strong opinions and like, that's why we want to put this data out. Like we just put it out a couple days ago. For some applications, it's really good. If someone comes and says like, I really need it for this specific use case, we're going to be there and try to run it because again, that iteration of like, it takes 3 seconds to run, that's probably not going to go away regardless of what the schema is. And so we're really just open to whatever comes. That's pretty much the answer I would give you.
Yeah, it's the second talk where I see people repartitioning Overture's data.
Sure.
So why don't they provide the correct partitioning, or do you talk to each other? So what is the best way to partition so it's efficient to?
Okay. Mark was saying something yesterday where Overture is like a couple years old at this point. And I'm talking about Overture, but a lot of these. I really want to point to this slide, and like Overture is the same thing. I think they want to put the data in first. Mark was saying something about this, about like, to really focus on the quality of the data, you have to have the data first. And I wouldn't be surprised if in like 2 years, this is completely irrelevant because Overture says, we're gonna do it this way now. And then there won't be a need for this. But again, like, to which data sets do we ingest? Like, we could do it in a few hours, and so we just did it, and now it makes a really cool demo. And even Jennings was showing it yesterday at the Overture workshop. So the answer is, like, we have to just try a bunch of stuff and we'll figure it out. And I agree, it's a bit confusing along the way and it's a bit messy. But I think that iteration speed, again, of like trying different things, and part of the reasons why we're putting this out, this one out as well, is to see, like, are people gonna use this? And if a month nobody's touched this, well, we're just gonna drop it and move on to the next thing. Cool. Well, if you want to talk about it more, there's Sina in the back, there's me here, and we're happy to have a chat with you guys. Thank you very much.